So tonight we'll talk a little bit about SQL. And SQL stands for Structured Query Language, just to get that abbreviation out of the way, acronym. And it's a language that's designed to allow both technical and non-technical users to query, manipulate, transform data from a relational database. So there are other databases such as NoSQL, which are not relational in how they work. They're different. They're outside the scope of this, and they're not used in the program at all either. So they do things a little bit differently, but having a strong grasp on relational databases is definitely worthwhile. And SQL at its base is very simplistic, and we can, just like any of the programming languages that we were learning and learned or continue to learn. At the base, at the core, what they do is very straightforward. However, we can build on top of them to make them very, very complex and use them to do very complex things. And SQL databases provide safe and scalable storage for millions, if not, I guess there's probably billions of websites out there, and mobile applications too. So tonight we're going to look at some SQL stuff using this W3 Schools TriSQL editor that I found, and we will see how it goes. Let me turn off my little ad script blocker thing. Not that I need to advertise Google, but sometimes it breaks things a little bit. I'm going to throw this into the Zoom chat just to make it easier if you want to save it for later. We're not going to do anything super interactive, like with me asking you guys to write queries or anything, but I think it's useful to have it. First question, how different is the syntax in things like MySQL, Microsoft SQL Server, etc.? So yes, there are many popular SQL databases. SQLite is the first one that you'll be exposed to in the program. If you try and put a project up on Heroku, you'll probably end up using Postgres for that. Oracle, Microsoft SQL Server all support the common SQL language standard. So that's what I am going to show you some of tonight. Each implementation will differ in the additional features and storage types it supports. So there is a common language standard so that there is interoperability between them all, and so that the community was like, if everything is different, this is just gonna not be good for the community at large. So I actually don't know that I've ever looked at the SQL language standard. Let's see, Common SQL. Okay, so Oracle strives to comply with industry accepted standards and participate actively in SQL standards committees. So I assume that Oracle's stuff is probably a reference, but with that, I would think that most people's SQL falls under it for the very general thing. Yeah, I would think it's a little bit like how different browsers implement W3C specs in different ways. But really, I think it's when you get down to specific features and how like varchars are implemented, which is, the type of data that you're going to be putting into a field, and floats and things like that, when it gets down to the more minute things. However, the syntax should be rather common, like operators and things like that. Queries from where groups having orders, selects, and such. So won't dive this deep into things, but we'll look at some of these types of things. So the first thing I want to do is, before we can really look at syntax, I want to show what a relational database actually is. So a relational database represents a collection of data in a two-dimensional table. And then databases typically contain multiple tables. And then each of the tables are similar to an Excel spreadsheet. So you're going to have rows and columns. And you're going to have a fixed number of columns. You can add columns. However, if you add columns, you're typically going to not have the data for what you already have there. So let's say, looking at this table we have here, I guess it'll be better at that size. If we were to add, say, customer name, contact name, address, city, postcode, country, a phone number. We could add a phone number column to this table. However, it would be insert and add to this table with all nulls for all of these people in here already. So typically we don't want to add columns. We want to understand our schema and how our tables are going to be set up from the beginning as best we can, so that we don't have to add to tables. We can do other things besides altering the way tables are set up. So we have this example table. It's a table of customers. In this database that W3 Schools gives us, we have multiple tables: customers, categories, employees, order details, orders, product, shippers, suppliers. So, some sort of business that sells things, their tables in their database. So this has data on, all these different types of things. And then we call it relational because we have these other tables that relate. They're related tables containing information about, different types of things that we might need. And the goal of SQL is to learn how to answer specific questions about the data. So, like, which country is purchasing the most? Or, how many orders are placed on certain days? And then that is used to help us make better decisions. So really thinking about SQL as kind of a way to organize our data and then retrieve data, and our queries are retrieving specific data that's going to help us make business decisions. So let's look at a select query. Now, that's how we're going to retrieve data from a SQL database. We already have one here. If we look at the top half of the screen, the SQL statement select star from customers. Star is going to mean, or I guess asterisk to be correct, is going to select everything, every column in this table. So select statements retrieve the data, and typically we call them queries. And it's just a statement that declares what data we're looking for, where to find it in the database, and optionally, how we want to transform it before it's returned. There is specific syntax, and that's what we're going to look at some. And we can think of our table as a entity, and then each instance of that as, each row. So we have, the whole table is the customers, then each row is a specific customer. So this would be one of our most basic SQL statements. And forgive me if I run into any stopping points this evening. Where I work, we use Microsoft SQL Server for everything. So I'm hoping that there isn't anything specific that isn't available here. But there should be ways to figure that out, and that might be interesting to do anyway. So now that we know how to get all the data from a table, let's break this down real quick. We have select. Select is going to tell us the columns that we want returned to us. And the from is going to tell us the table that we want it from. So if we just wanted the customer name, we could take out this star and put customer name. We run that and we just get all the customer names. A common pattern in writing SQL select queries is to start with your star and then narrow it down from there if you don't know your schema well enough. There can be hundreds or thousands of tables in databases that I work with on a daily basis. And sometimes I really don't know all the columns that are available to me. So I'll select star from something and see what it is. And then from there, narrow it down, because it does take more time to return all the columns from a database. So as things scale, you probably won't experience this while you're in the program, but when you scale to really large databases, it can take very long periods of time to run if you're returning extra data that you don't need. So knowing how to write just to what you need can really be beneficial in saving some time when you get to that scale. So we want to write some queries now that return some data that fits specific constraints. So not just picking a column, but we talked about how we might want a query that we want only specific types of data in. So we can think about that as kind of filtering the data and returning it to us instead of saying let's just go through it bit by bit and find what we need. On a table with 91 records, it might not be too hard, but on a table with 9 million, it definitely becomes something that we should task our computers to. So let's say we wanted a table, we wanted to find out, just the customers in Germany, because, we're going to run some special in Germany, or we only want to send a mailing to people in Germany. We would add on to this statement a where clause. We can say where country equals, and we're going to want to make it a string, Germany. And get only our customers in Germany. And let's see, looks like everybody is in different cities. But we can add to these where clauses. So the where clause is going to be our filter, and we can make it as complex or as simple as we want. And we do that using and or statements or keywords. So we can say, and also you don't have to put your SQL in caps. That is just a convention, but it's not required. It'll still work with lowercase. It's just something that I've gotten accustomed to doing. I hit my caps lock key a lot doing this. And let's say this probably won't be very useful, but postal code greater than, let's say, 30,000. So we should be filtering out this first one, this one. And this is making a guess that postal code is in this database as a number. Error, data type mismatch. This most likely means that this is a string. Yes. And that makes sense because this postal code is probably coming from some sort of user input as was dealt with in the CLI project, all the user input coming in as strings type of thing, or in any type of form, even if people are entering a number, if they're typing it in, it's coming in as a string. So this is being stored as a string. And there, so now we've tacked on another conditional. Now, I'm going to go through a couple of the other operators. We'll leave Germany on there just to look at them. So we have a not equals. And that'll give us, oh, it refreshed. Let's get this. Oh, so what's happening here is this not equals is a numerical operator, but I'm trying to call it on a string. So what I need to do here is use a different operator. I'll call not. Country not Germany. All right, let's see. What might be missing here? Syntax error. These are the things that I wasn't sure about in this little online. Okay. So not in is actually used. Let's just use in as the example. So in, we say in Germany. Now what in is going to do is allow you to compare to a list. I'm not sure why not equals didn't work before, but either way, so we can say in, and we can make this into a list of strings. Does anybody remember another country? Belgium, maybe? Was that in the list? Yes. And then we have the opposite of that, not in this list. So everything that isn't Germany or Belgium for the country. I'm going to go back to the postal code. Or we'll just use the customer ID. Let's go to customer ID. And another operator we can use is between. So we say between 10 and 25. And this is going to give us all the customers where customer ID is between 10 and 25. And we can say not between. And we can also have our OR statements. Let's say customer ID equals 5. or customer ID equals 10. And so on and so forth. So we can make these more complex, less complex. This also follows the standard parenthetical? Oh, maybe not parenthetical, but the order of operations with parentheses. So if you wanted to make this a more complex statement, you know, and country equals, let's say, Sweden, it's going to match an or against this whole statement. And that should get rid of this one because country is Canada. I think I remember what I was wanting to do before, or what. So equal is going to work because that's the equality, but is the keyword I was looking for a string. No, value use of is operator. I'm wondering what database this is based on. Either way. Okay, so let's get a query back again. Okay, let's see. Okay, so I'm remembering it. I don't have to do not equals often. So equals is going to be a case-sensitive exact string comparison. Then I don't know what to call it. The almost a fish, because that's a fish. The diamond, the sideways diamond, is the not equals to case-sensitive exact string inequality comparison. So this is one of those things where, depending on the database, if it's MySQL, Microsoft SQL Server, and such, this might work, or this might work. This is actually what Microsoft SQL Server uses. I just don't ever use it. So there's our not equals for the string. We also have a useful one, which is like. So let's find something. Here we go. Let's say we're postal code like. Now, like is going to allow us to match partial strings. And there's also a not like. Like is also going to be case insensitive. So if you want to match an exact string, but be case sensitive, we could do something like Germany. It's supposed to be case insensitive. Germany. Oh wait, I'm on postal code. To comment out SQL, dash dash. To comment out blocks of SQL is /star, and then // to close it. Useful when you're playing around with things and want to try multiple different things and see what gets you where you need to go, or just want to save something. So let's say where country like Germany. Missing operator. Okay, so it doesn't like commented out code in this scenario, but commented out code shouldn't be read in a typical SQL statement. So we see that is case insensitive. Now, if we look back at postal code, they say like, we can throw a %, and that's going to be a wildcard. It's going to be used anywhere in a string to match a sequence of 0 or more characters. So if I put a 6 here, we're going to say anything that starts with a 6 and then has anything else after that, we should match. So we see we got these 4 postal codes. If we made it 6, 8, we only get 1. Or 6, and we're going to get all the ones that start with a 6. And yeah, I already showed you in for a list and not in, it's opposite. Another thing we can do is use, let's see if there's a good example here. 6. If we don't want to match multiple characters, we can use an underscore. So if we said 6, no, these are duplicates. Let's see 1. Here we go. We have multiple 1 zeros. So let's say 1, 0. We see some of them are 4 digits, some of them are 5 digits. So let's say 1, 0, underscore, underscore. We run that. We're only going to get 4-digit postal codes that start with 1, 0. Can regular expressions be used in SQL? I'm honestly not sure. Knowing that the standard of regular expressions, I would think that there's a way to do it. Yes. So I think it's going to be some sort of function inside of the SQL database that you're using. So we see here, we setting a string pattern, or this is C#. Rare expressions inside SQL Server. So yeah, there's this PATI index. Which takes a pattern. Transact SQL is what SQL Server uses and such. But it looks like that would be how it's done with Microsoft SQL Server. SQL Server 2000 plus supports regex. But the catch is you have to create the UDF function in CLR before you have the ability. I don't know what that means. But it is possible. All right, let's see what else. Let's do a so even though the data in our database might be unique, the results of specific queries might not be. So in this customers database, we have many different customers in, let's say, Germany. So we can actually get rid of duplicate rows based on a column name. And this is just the most basic way to do this. Select distinct, and let's say country. And we see just our countries, and we only see them all once. Now, the distinct keyword is going to be blindly removing duplicate rows in this result. It doesn't delete them, it's just what it's showing us. So we'll see different ways to do this. We see we have 21 different countries, number of records, 21. And let's get back to star. Another select statement that we can do is to order our data. So let's say, well, we don't need a where. Let's just do an order by. We can say, I think postal code makes the most sense. And by default, SQL is going to order things in an ascending order. To change that, we can tack on a descending here. It goes the other way. Ascending, typically, in most of my experience, isn't what you want because you're looking for things, well, I guess it depends on the type of data you're looking for, but a lot of times you're looking for things that are, let's look at our orders table. Dates. So if we wanted to find the most recent order, we'd say order by, order date. That would be oldest to newest. And we would say descending. We get newest to oldest. This business is probably out of business because their last order was, what's that, 21 years ago? All right. Now let's look at some basic joins. So up to now, we've been looking at single tables. However, real world, like this database is showing us, typically has data broken down into multiple tables. And those tables reference each other by IDs. So we say, and the reason they reference by IDs, so we see this table only has, pretty much numbers in it, even though we're in an order, we have an associated customer. We were just looking at the customers table and know all the data that comes with. We have an employee, we have a shipper ID. So we're referencing 3 different other tables. Is that these numbers are very tiny to store. So they save a ton of disk space as opposed to putting a customer name in here and such. With that, it also makes it much quicker to get queries back. So this is called database normalization. And this is done and is useful because it minimizes duplicate data in a table. And it allows the data also to grow independently of each other. So, if we had 100 other customers that, signed up, we wouldn't have to worry about any new shippers. that could independently, and suppliers can all independently be taken care of without worrying about what's going on in the other tables. A trade-off is that our queries are going to get a little bit more complex because we have to look at different tables for different things. And then, depending on the size of the tables, when we're looking at multiple large tables, performance can decrease some. But the trade-off is worth it in the end of organization. So we have to learn how to connect the tables, and we do that through joins. Now, let's get some customer data for these orders. Let's get back to orders. So in this query, we're going to work from the top down. Right now we have everything. The first thing we want to do is we'll do an inner join. Now, depending on the SQL, well, not depending, an inner join is the default join. So if you do a join, it's going to be an inner join. I believe I might need to explicitly state that here, but I want to show that. So if you do a join, it's going to be an inner join. An inner join means take everything from both tables, no matter what. And you pick the table you want to connect to. So in this case, let's say customers. And then you have to tell it how to connect. So we say on. So this needs a piece of shared information. In our case, it's going to be the customer ID. The customer ID in our customers table is going to equate to the customer ID in our orders table. We're going to say, if we see customer ID 90 in our orders table, we want to get the information that customer ID 90, that row has in the customers table. So we have to tell it to connect on that column. It's kind of like, sewing it together right there on that ID. So you have to tell it which table and which column to connect with. So we're going to say orders dot customer ID equals customers dot customer ID. And this should bring back everything. I don't know if it will. Okay, syntax error. I believe it doesn't like our star. So let's say orders.star, customers.star, if that does it for us. No. Okay. So let's just give it some columns. Orders.order ID. Say customers, customer name, and then say orders.order date. Select orders.order ID from orders customers on customer ID. Space, it shouldn't matter.
Seth, check out the spelling of orders on the line with join. That might be it.
That's it, probably. There we go. Let's step back. This should work. Yes. Okay, so there we go. And if we see, we take this inner join out, just do a join. Okay, it doesn't like not inner joins in this triad editor. So now we have data from both tables. And now we can filter based on that data from both tables. So we can say, where employee ID is greater than 3 and country equals Mexico. We get only orders that were from customers in Mexico where employee ID greater than 3 had it. Now we're using data from both tables together. Oh, I wasn't looking at the chat. Good job with pointing out the typo. I still wish that the Zoom chat had some sort of noise so I knew when people were typing in there. I have 2 screens, so I'm head into my other screen, not looking at the chat window. But thanks. So yeah, that's our basic join. There are other types of joins. I think this. I was hoping it was all of them. There's an inner join, which is going to have records that have matching values in both tables. There's a left, with everything else is considered a quote-unquote outer join, but a left outer join is going to return all records from the left table and the matched records from the right table. Right outer join is return all records from the right table and the matched records from the left table. A full outer join return all the records when there is a match in either left or right table. I honestly have never delved deep enough into SQL to use anything outside of an inner join or just a join. I find it works well enough, unless you're going to be writing really complex SQL queries and doing, SQL development type of stuff, SQL engineering type of stuff, when you really want to limit the amount of data that, or what type of data you want to include and exclude through your joins. I find that just, if it matches, bring it in, let's do it, and get all the data type of join. Good enough for everything that I've ever had to do. So it's worth knowing that there's other types of joins and understanding how they work. However, for practicality's sake, I've never really had to use anything outside of an inner join in my experience. We can also join multiple tables. It doesn't have to be just 2. So we can say, let's limit this sum to orders.order ID. Let's see if we can do this. So you should be able to have aliases for these tables. Say as O, customers as C. So now we should be able to truncate these down. And we'll see if this works or not. And because these are unique, employee ID and country, we're not going to run into any errors. If both tables had a column named country or employee ID, we would have to define those. There we go. And it's showing us, O.customer ID, these are the ones in that table, and these are the ones in this table. So now we can do O.order ID, C.customer name. And let's see, we have these shipper IDs. Let's see who shipped these things. Let's do another inner join. Shippers as S on. So the shipper ID is in our orders table. So we're going to do O.shipper ID equals S.shipper ID. And then I'm going to guess that there's a shipper name. No. Okay. And we're just going to copy this, and let's see what's in this table. There is a shipper name. Shipper ID. All right. Missing operator. Let's see. What might be missing? Might need to. This might be because of this. Okay. So I wrap the from in parentheses. Like I said, this is a very kind of limited and not always the way that these SQL statements would be written, I think, today, but this implementation has needing parentheses around this statement. I don't need parentheses in my day-to-day, so that might be something specific to this. Basically just saying, building out a larger, we're connecting this, or with our parentheses, we're connecting this statement, and then we're connecting this next statement. But we have multiple things here. And now we can say, where s.shipping name equals federal shipping. Oh, shipper, not shipping. We're getting data from 3 different tables and filtering on it. So I think that's a good place to stop on this. I want to give you some resources in the chat. We have W3 Schools, which is where this is hosted. If you want something for when you're on the go, Solo Learn has apps, iPhone, Google Play, or on the web, and they have a SQL course in there. It's very much along the lines of what I've shown this evening. Very introductory, very get started, but a little bit more in depth with little quizzes built in after every lesson. So, you learn, here's a select statement, and then the next, right after that, it says, how do you select all from a table and such to really reinforce it. And then another site that I came across is SQLbolt.com. This is interactive tutorials, has 18 lessons. So you do it, you learn something, and then at the bottom it has a task. You have to pass the task before you're quote unquote allowed, but you can just click if you want to. So yeah, those are great places to brush up on these things outside of the resources that Flatiron provides. Any questions this evening about anything that we've gone over? We did some select statements, we did some joins, we did some filtering. We looked at, how to filter numerically and how to order by. And we looked at distinct, to get distinct values from a column.
I actually have a question because I'm working on the SQL lab, and I'm a bit stuck with the with what I think it's wanting me to do, like an addition or subtraction. Can I just share my screen real quick? It shouldn't take more than a minute or two. So I know you have another thing coming up.
Yeah, let me stop recording real quick.